share my screen. And we'll get started. So if you're seeing my screen, it says, which expression is equivalent to the square root of 120x? So this is really, it's really two questions. It's what is the square root of 120 times the square root of x? You can actually break this apart that way. And the number you break apart using a factor tree. So you have to remember your prime numbers. You start with 2. 2 times 60 gets you back. And you keep trying 2 until it doesn't work anymore. And then you go to your next prime number, which is 3. And you're done when you have all primes on the leaves of this tree. And then you circle pairs. The reason you circle pairs is because there's actually a 2 here, even though it's not written. It's a square root. Square means 2. Okay, so for each pair you can bring a number out. So it's 2 square root, and then whatever is left over goes on the inside. And then there's still that square root of x that's lingering. So this becomes 2 times the square root of 30, and then you can combine that x underneath there.
Okay.
Any questions on that?
No.
No? Okay. We're going to do 9 next. I should have started with 9. It's actually slightly easier. Maybe even 10 as well. But we're gonna move from square roots to cube roots and then fourth roots. You will eventually see a pattern here. So this one, you're gonna just break this apart with that factor tree and that prime factorization. So you start with 2 and you get 100 here. Now what some teachers say, and I think it's a good strategy, is to you look for the biggest square root that goes in, or biggest number that you know that the square root. So you could actually stop here, but I'm going to keep going just because if you continue this recipe, you'll see that what I do always works here, whether you recognize it or not. There. So you circle your pairs. And you can see there's one left over, one leaf left over. So you bring the 2 out, you bring the 5 out, and we're talking about out of the square root. So you have a 2 and a 5 on the outside, square root of what's left over, which is a 2 on the inside. And so that's 10 square root 2. It's really all about this prime factorization over here on the left.
Okay.
All right, I'd like to move on to question 10, unless there's some things about 9 which are unclear.
No.
Okay.
I can see.
Okay, so 10 has the appearance of being different, but we're actually just going to take do a prime factorization of that number under the square root. So we're gonna come back to this part on the right, but for now we're gonna ignore it. We're just gonna work on this. So if you have a calculator, you're just dividing by 2 until you can't divide by 2 anymore. Okay, and now I can't divide by 2 because that's an odd number. So again, your next prime is 3. 3 works, 3 and 27. What you don't want to do is jump to like 9, even though it is 9 times 9. That works, but it's like you want to like learn the recipe, and then later on you can jump to some of those things. So notice there's 2s and 3s. Okay, there's 3 2s. We almost have to write it. We have to say 3 2s, and there are 4 3s.
Yeah, I see that.
So we started out with the square root of 648. And what we're really saying is that it's really 2 times 2 times 2. That's the 3 2s. Times 3 times 3 times 3 times 3. 4 3s. Or what they're asking for is it's 2 to the power of 3 because there's 3 of them, times 3 to the power of 4 because there's 4 of them. And so when the problem asks you the square root of 2 to the a times 3 to the b, they're asking for these two exponents here.
Oh, so how many times we got both numbers?
Exactly. So in your problem, a is 3, that's a, and b is 4.
Oh,
But it comes from like in this problem, we did the same thing we did in all the other problems. We built this tree. This time, rather than like bringing numbers out, I had you just write them under the root,
mhm.
and then you just count them. Well, there's 3 2s, there's 4 3s. It's easy to mix these numbers up. Just be very careful there with that. That's why I wrote out the word 3 and kept the 2 as a number.
Yeah. It's really easy.
That this problem is intentionally difficult for that reason.
Don't you love math teachers?
Well, if the goal is deception, this is fairly successful. So, all right. Real question is like, could you replicate this on your own? This is a good example. Like if you have time to look back at it later, and if we get done early, we can do some more like this.
Okay. Yeah.
All right. So the next problem I'm going to go to is I guess number. Oh boy, it's number 8.
Okay. It's really complicated after that one. So.
Yeah. All right. So here's number 8. Believe it or not, we're gonna break this apart, and there's gonna be some things that are not all that difficult about doing this. So the first thing we're doing is figure out what is the square root of 128.
Mhm.
So you got to do the same thing you've been doing: 2 times 64, 2 times 32, 2 times 16, 2 times 8, 2 times 4, and then 2 times 2. Now you might be able to stop at some point and do it faster. But this recipe I'm showing you always works. You circle the pairs. Okay, and for each pair you bring 1 out. So you bring 2 out, 2 out, 2 out. So it's 2 times 2 times 2 square root of what's left over, which is 2, which is 8 square root 2. Is that okay?
Yeah.
Okay. So that takes care of the number. Okay, now the next thing we've got here is, I don't need these equal signs, is the square root of x to the 8th. So if you recall, there's really a 2 here. And so to simplify this, we can go into this factor tree, but you just take the exponent and you divide it by 2.
Okay.
Maybe you saw that in a video, maybe you didn't. So what that says is that you bring out an x to the 4th. So this thing right here becomes x to the 4th. So when this exponent is perfectly divided by this number, you get something really nice.
Right.
Okay, so far our answer is 8 square root 2 times x to the 4th. So these two can combine, and we'll get to that later. But like if this were it, this would be our final answer, but we're gonna have to keep going here with this other stuff. Okay, so the next one is the square root of y cubed. So this is a problem. Okay, now there's a couple of ways to look at this, and I think this will be the best way for you. This is the square root of y squared times y.
Mhm.
Do you see how I got that? Because the 2 and the 1
Yes.
add up to 3. So it's really the square root of y squared times the square root of y. There's really a 2 here. What is 2 divided by 2?
0.
1.
1.
1. So you have y to the 1 square root of y. Now, if you didn't like that, we can do this another way, but I'll save that for another problem. So the next one is the square root of z to the 9th. And it's really like z to the 8th times z. So it's the square root of z to the 8th times the square root of z. And
Yeah.
z to the 8th is like x to the 8th. 8 divided by 2 is 4. So it's z to the 4th times square root of z. Is that okay?
Sorry, I'm just catching up.
Sorry if I'm going too fast. I could definitely slow down here a little bit.
Yeah.
So what you do is you try to make this exponent, if it doesn't perfectly divide, like 8 perfectly divided by 2, but 3 does not divide by 2, so you turn the 3 into a 2 and a 1 to get something that does perfectly divide by 2. And same
Right.
thing with the 9, you make it an 8 and a 1 because 8 perfectly divides by 2. Okay, so now if we look down here at our so we have y square root y, z to the 4th square root z. And so what I was trying to show you earlier is you can combine certain stuff. Like I'm going to get rid of this line here. You can combine the stuff that's outside the root. So outside the root, there's this part outside the root, and then there's this part inside the root.
Right.
So the part outside the root is the 8, the x to the 4th, the y, the z to the 4th. Inside the root is the 2, the y, and the z.
Oh, okay.
So whatever comes out stays out, and whatever is in stays in.
Mm-hmm.
And that's your final answer.
Okay. That makes sense.
Fantastic. Okay, let's go to cube roots, and let's do number 7. Let's go to number 1. Let's go to number 1. Okay, which expression is equivalent to the cube root or the third root of this? So it's really 3 things. It's the cube root of 256 times the cube root of x to the 10th times the cube root of y to the 7th. And you really want to look at these as like 3 distinct paths, three runways, if you will. Okay, and we got to, figure out each of these. So the one on the left, you build this thing that we've been doing before. Okay. 2 and 32, 2 and 16, 2 and 8, 2 and 4, and then 2 and 2. But now, what's different now, I know you're probably still catching up. What's different now is because it's a cube root, you're looking for triplets instead of pairs. So you circle triplets. And so there's got to be 3. And if there's not 3, well, they don't come out. So for each triplet, 1 comes out. And it all depends on this number up here in the top left. If it's 2, then you need a pair. If it's 3, you need triples. If it's 4, you need 4s. Okay.
Okay.
So the 2 and the 2 come out, cube root of whatever's left over, which is those 2's there. It always multiplies. So it becomes 4 cube root of 4. Is that okay? Is that clear? You do the number part, you look for, you always make this tree, the tree is what it is, and then it tells you that number there.
Mm-hmm.
So the next one we're going to do slightly differently. Again, there's kind of a couple ways to do it. I'll show you this because maybe you'll like this better. 10 divided by 3, which you haven't done probably in forever. 10 is the exponent, 3 is the root. 10 divided by 3, if it took you back to like 3rd or 4th grade, you would say it's 3 with a remainder of 1. Do you remember that?
Oh yeah, yes.
Okay. So here's why that's important. This becomes this right here, x cubed, cube root x to the 1. So this 3 right here in front is that exponent. This one right here is this exponent.
Okay, yeah.
Okay. Now we're gonna do the same thing over here. We'll see if you like it. It's 7 divided by 3, which is 2 with a remainder of 1. 7 divided by 3 is 2 with a remainder of 1. So this becomes y squared. That 2 comes there. Cube root y to the power of 1.
Yeah. I see that.
Okay, now let me, before we're going to finish this up, but let me go back to the previous problem and show you why this is so important. Let's do 3. See, remember in this previous problem it was 3 and 2. What is 3 divided by 2? Well, it's 1 with a remainder of 1. So
Mhm.
notice this first one is there, and this one is there.
Yeah, I see that.
Okay, how about 9 divided by 2? Well, it's 4 with a remainder of 1. Look where that 4 is. Look where that 1 is.
Yeah, that makes sense.
Okay, perfect. Because that's how we're going to do the next assignment, or not
Mhm.
next time, next problems, because it is truly much faster. So again, we're kind of down to this. Here's x cubed, cube root of x to the 1, y squared, cube root of y to the 1. So we've got the parts outside the root, and then we've got the parts inside the root. And we have 4xy. Is that okay?
Yeah, I'm just catching up.
Okay.
I am confused though, because I don't see that as an answer.
Well, let's take a look here. It is possible that they have okay, so we got an x cubed, 2, 4, cube root of 4, 64 times 4. I think it's just a mistake in your answer space. Guess I would tell you to go with letter B because it's the closest one.
Okay.
Sorry about that. That's definitely not, what was intended here. Let's look at number 5, and hopefully this one, I'll be a little more careful to make sure we actually get something that matches. I know in the past we've had some that just haven't lined up.
Yeah, I don't know why that happens, but it does for whatever reason.
So we got the cube root of 32, the cube root of x to the 8th, and the cube root of y to the 10th. So 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So for those right there, you're going to bring 1 out. So it's the 2 cube root of 4. Okay, and that's pretty similar to the last problem.
Yeah.
Okay, now here, the second one, you do 8 divided by 3, which is 2 with a remainder of 2.
Mhm.
2 that's left over. So that it becomes x squared cube root x squared. And then we do the same thing with this last one. 10 divided by 3 is 3 with a remainder of 1. It becomes y cubed cube root of y to the 1. Okay. So now we've got the part that's outside the root, the 2, Just check here, make sure we actually have something here. 2x squared y cubed cube root 4x squared y. And we have a winner. One of the things your instructor is doing, the reason they're putting parentheses here in the answer space is sometimes this exponent gets like there, this root gets there.
Yeah, I see why they could do that.
Yeah. All right, so let's do number 7 next.
Okay.
7. All right. Have you been able to do some work on your own the last few weeks, or you just paused on math? I mean, how's everything going in class?
I was able to do some stuff on my own, and it's just been really busy with the college courses. I'm still
Yes.
not done. Chemistry, like having 3 exams and like studying for them.
Yes, lots.
I still bombed my last one. I was so mad at myself for that. But
Keep trying. Don't get too down. Just keep working, and you'll be there in no time.
I blame it on getting sick. I got sick the week before, so I had to cram like all my studying
Oh no,
in for
yeah.
only 1 week, and it just like
Yeah, it's tough to
thing.
do. College students know all too well. If you get sick, you can just lose a lot on your classes. All right, well, let's take a look at another problem here. I've just split it up. You don't have to do this, but this is kind of a nice way to just separate the problem into the parts that need to be done. You'll see that the cube root of 27 is perfect. It's just 3.
Right. Okay.
So that's nice. Whenever these numbers match or it's a multiple, like let's say it was the cube root of a to the 6th, 6 divided by 3 is 2, 3 divided by 3 is 1. It's perfect. It just comes out.
Okay.
There's nothing left inside. But here we've got 7 divided by 3, which is 2 with a remainder of 1. That becomes b squared cube root b to the power of 1.
Okay.
Okay, so again, it's like, well, what's left over? Well, there's 3ab squared cube root b to the 1.
Okay. I see that.
And that should hopefully match one that's there.
Yes, it did.
Okay,
Okay.
great. So let's go to 3. 3 is kind of awkward. You got to do the problem and then figure out which exponent matches. Oh, they don't even, okay. Ooh, all right. Oh boy. This is a really tough problem because there's both a forwards and a backwards component. And just as a student, I know when you see symbolic stuff, it's just very awful. So
Yes,
yeah, so the easier part here is going to be figuring out y to the 5th, y to the d. Okay.
Okay.
So we know it's take the 5 and divided by 3, which is 1 with a remainder of 2.
Right.
And so where's the 1? The 1 is right there, like that matches. That's good. Yay, check. The 2 is what goes here. So we know that d equals 2. Okay.
Oh, okay.
Now that's the thing is though, with the way the multiple choice is done, that in best case would get you down. Well, best case that would be the only 2, but there's 2 of them. So
I know.
right. So it's either, and I don't like to use the multiple choice, but it's one way to do this problem that's reasonable. So it's either c equals 2, d equals 2, or it's c equals 6, d equals 2.
Right.
Okay. Now, whatever c is, c divided by 3 has to equal 2. So
So
I
it's
got
gonna
that.
be 6.
It's going to be 6. Yeah.
Okay.
It's kind of one of those backwards problems, and it's stepping it through is helpful. You might think to do this 162, but that actually doesn't help you at all doing this problem.
Yeah.
You got to go right to the exponents. All right, we're going to come back to 4. We're going to do 6 next. 4 is definitely the most difficult problem on here. I don't know why it's
I don't know why they have to go so crazy.
yeah, it's like they don't realize you gotta, you don't run a marathon, you start, walking, crawling, walking, things like that. So oops, this is not the right one. Sorry about that.
That's
Snip the other one. So the general, like when you generalize these problems, and that's what this one is all about. You're generalizing. So it doesn't matter, whatever the root is, whatever the exponent is, it's always the exponent divided by the root.
right.
So it's 10 divided by 4, which is 2 with a remainder of 2.
Mm-hmm.
And you probably haven't written this in a while because we use calculators or phones, but this is the right way to do it, because that tells you, oh, it's x squared,
Right.
4th root, and then x squared inside here. So yeah, they can both match. If that's, if you're unsure about that.
Right.
So the correct answer looks like it's A because it matches this, but we won't do this, but if I give you the 7th root of x to the 91st power, you just do 91 divided by 7.
Exactly.
All right, so let's go back to question 4. Yeah. Did we get to all the other ones? Is 4 the only one that remains?
Yes, it is.
Okay, good. I like when we can do them kind of the right order here. So there's a couple approaches here to doing this problem. One is to actually evaluate what's inside the root first, like and do some cancellations and stuff. I'd have to, let me look at the answer space to tell you what to do. Interesting. Ooh, yeah, I guess.
Clarify for C, that's not like a times, it's supposed to just be an X.
Okay. Okay. Yeah. No, let's I'm not sure. Let's go. Let's just do the ooh, boy, I really okay. We're gonna just do what's inside the root here first.
Okay.
So what I mean by that is we're gonna reduce 24 over 128.
Oh, okay.
X to the 6 over x to the 4th, y to the 1st over y to the 5th. Okay, so the first one there, I don't know if the 4 divided by 128. I got my fancy calculator. It's 4 over 23. Which I'm looking here. Why would they do that? Maybe they didn't do it this way. Sorry, I'm really struggling here with how to, because I don't want to create unnecessary confusion. I feel like I'm about to do that. Let's go the other way. Let's say it was the 4th root, 24x to the 6th, y to the 1st. Okay, so that's the numerator. So 24, if we try and break apart 24, nothing works. So that stays inside. 6 divided by 4 is 1 with a remainder of 2. So that tells you that an x to the 1 comes out. 4th root of what's left over, 24x squared y the 1. So whenever the exponent is less than the number on the outside, you can't do anything about it. It just stays there. So that's the numerator.
Okay.
Now we're going to do the 4th root of 128 x to the 4th, y to the 5th. So that 128, 2 and 64, 2 and 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. So we got there's 4 2s, so we can bring one out, and then there's 3 left over. So there's a 2 that comes out. 4th root of what's left over is there's an 8, because there's 2 times 2 times 2.
Right.
Now this 4 divided by 4 gets an x out here.
Okay.
5 divided by 4 gets you 1 with a remainder of 1. So 1y comes out, but 1y is left over inside. Do you see that?
Yeah.
Okay. Now on the left here, we still need to simplify this. So on the left here, the x's cancel.
Okay.
So it's 1 over 2y, and then it's the 4th root of, and we can actually like put this stuff that's under the root back inside the root. And so you can see the y's cancel, and 24 divided by 8 is 3. So it becomes 1 over 2y, 4th root of 3x squared.
Okay.
And then they just combine the numerator. So it becomes 4th root of 3x squared over 2y. They multiply that together. If that problem wasn't cleared, I would not worry about that. The other ones were much more realistic or representative of what you might see on a test or quiz most of the time.
Okay. Because even though I followed you and I get what you did and why you did it, but it's still like I don't think I could really replicate it like a lot.
Right. So we've got some time left. Should we do some practice problems? Do you have some other things you would like us to do?
Sure.
Okay, so let's do this. Let's make it fairly simple. Let's go with the square root of 16, x to the 10th, y to the 12th. Okay, and as you're thinking about this, I'm going to write it out. This is really the problem that you have to be really comfortable doing. Okay, so could you give that a try, please, and let me know what you come up with?
Mm-hmm. So I got 4x to the 5th power and y to the 6th power.
Perfect. Okay. So notice, like you said, when they all, like 10 is evenly divisible by 2 and 12 is evenly divisible by 2, you get something perfect like this.
Mm-hmm.
Fantastic. So let's try another one here. I'll make this one slightly more difficult if I can get this up. I'm gonna just hang on, stand by, technical difficulties. There we go. All right, so this time let's do the cube root of 27 x to the 10th, y to the 12th.
Okay.
And I'll just write this out, but you don't have to do this. It's just a good reminder that it's really three separate paths here that you're on.
Okay, I got 3x squared y to the fourth power, and then cube square root of x.
Okay,
Right.
so I only heard one thing here. 10 divided by 3 is 3 with a remainder of 1. So there
Oh,
should be a 3
yeah.
there. I heard 2, but maybe.
No, I divided it right. I just put the wrong thing there.
Yeah, and it's easy to, you almost have to draw like somehow a block between these because they're really separate things here.
Mhm.
Okay, so let's try another one here. Let's go fifth root 64 x to the 12th y to the 19th.
Okay.
How are you doing on this one?
Almost done.
Great.
Okay.
Okay.
So
Do you have a
2x to the squared power, y to the third power, and cubed power, and in
the fifth
five,
root? Yep,
the
fifth
fifth
root.
root,
Yep.
fifth root, I got x to the square power and y to the fourth power.
Yes. Now it does not matter to me because this is not an English class, but I'll just, it's okay to say x to the power of 2, y to the power of 3, or x squared, y cubed. We only have a few of those. We have squared, cubed, quartic, maybe, but most people just go x to the power of 2, y to the power of 3. And then this is the fifth root, or the square root, or the cube root, or the sixth root, or the fourth root. It doesn't really matter. It really not, super important. It's just, all right, so let's try another one here. What's the square root of 96x? This is closer to one of the first problems we did today. I'm just going to start working this out off to the side here.
So I got 4 outside in the square root 6x.
Perfect. Awesome. Good job. All right. Well, that does take us to the end of our lesson for today. I think you got a lot out of those additional problems you're able to work through. So if you have time, maybe work out some of the ones again, but I'll send you the notes and the screen recording, and I'll see you next time.
Thank you.
You're welcome. Bye now.
Day.